we are still working on that 6.1 homework. We're on problem 28. So we started talking about problem 28, and we have this table of values, and we were going to do the upper and lower estimate to get the total quantity of oil just after 5 hours. So we're not going to do the entire row here, everything just for the first 5 hours. Again, we're going to make each of our rectangles 1 hour wide, and for our LRAM, which is going to be an under approximation because this is a strictly increasing leakage here. So the leakage gallons per hour is always increasing, so the LRAM is always going to fall under that curve. That'll be an under approximation, and the RRAM will be an over approximation. So if we just look at those numbers for the first 5 hours, let's take a look at that. I'm going to use, for the LRAM, I'm going to start with that time zero value, 50, 70, 97, 136, and 190. Multiply all those rectangles by their width, which was 1, and I get 543 gallons. And that's going to be a lower approximation because that is an increasing function. And then for the RRAM, again, I'm going to start at the 70. I'm not going to use the first term. I'm going to start at the 70, and then for the first 5 hours, and then use that 5th hour value of 265 to get an upper approximation of 758. And what this is telling us is the actual value has to fall somewhere between these two values. So for the rest of number 28, let's see what it says here. For 8 hours, okay, so to do 8 hours instead of 5 hours, I'm just going to use all of the data values. So let's take a look at that. And I'm going to use that first 50 and then go all the way to the second to last one. This is the 7th hour gallons per hour rate. And we use all of those. And then for the RRAM, I'm going to start at the 70, again the second number, and then I'm going to find the last value, the 8th hour, and to find those 8 rectangles. Again, both cases we're using 8 rectangles with the width of 1, but the LRAM uses the first value and RRAM uses the last value. And so here is the two values for the L and the RRAM for all 8 hours. So that would be how much oil has escaped after 8 hours. And now here's an interesting little follow-up here. It says the tanker continued to leak at that same value, 720 gallons per hour. So after 8 hours, it's just going to stay constantly leaking that much oil until it's out. So it originally contained 25,000 gallons of oil, and then how many more hours will elapse in the worst case before all the oil has leaked in the best case. So the LRAM would be kind of our best case scenario because it's leaking out slower or losing less, and the RRAM would be kind of best case. But either way, those two will trap the two values. So I have 25,000 gallons of oil, and for every hour after 8 hours, I'm going to lose 720 more gallons of oil. So it's kind of a linear relationship here. So if I set up little equations for that, I can look at my LRAM, which I already lost 1,693, and then I'm going to add 720 T to that, and then that's equal to 25,000 to back solve how much more time it's going to take. And then for the other case, I'm going to use the RRAM value, and then the 2363 to figure out how many more hours it's going to take to leak all of that 25,000 gallons. So between these two values is where the actual time is going to occur. So that's number 28 in that problem. So just a couple more left here on this homework. Next up is 31. So 31, again, I got a positive, continuous, increasing function on some interval a to b. Again, we like to do a comma b. Then LRAM gives an area estimate that is less than the true area under the curve. So is that true or false? And then justify your answer. So if I'm looking at that, I'm going to go back up to my 31. Here it is right here. And so I just drew an increasing function. This is always positive, always increasing. And if I draw in little LRAMs, I'm noticing that those rectangles will always fall below the function. So that LRAM will be an under approximation. It will underestimate the area under the curve. So that is true. And then next up is 35. So now we're getting into a little of the sine function. So how do we use an LRAM to approximate the area under that sine curve, that first hump from 0 to pi? Because sine at 0 is 0, then it goes up to 1, and then comes back to 0 at pi. So what is the area under that curve? And if I wanted to use 4 subdivisions, so I would go from 0 to pi, so that's the a to b is from 0 to pi, and then the b minus a over n to get my interval width would be pi minus 0 over 4. So what that's telling me is the width of each of the rectangles. So that's lining up for all of these choices. So each rectangle width is going to be pi over 4, because then 4 of those would give me the full length of pi. Okay, so now I need the function value. So for an LRAM, I'm going to put in f of 0, f of pi over 4, f of 2 pi over 4 or pi over 2, and f of 3 pi over 4. So those are the function, the x values I'm going to plug in. So it's not going to be these, because those are the x values. I want to put these x values into the function. So it's not a, and if I do that, if I put 0 into the sine function, again moving my arm, sine of 0 is 0, and then sine of pi over 4, either on your calculator or just making your little reference triangle, is 1 over root 2, or root 2 over 2. And then sine of pi over 2 is going to be 1. So it's looking like this is matching up here, this choice C. And then sine of 3 pi over 4 is going to be, again, that's a 45-degree reference triangle over in quadrant 2. So that is still going to be 1 over root 2. So each of these are the height. So it's looking like this choice C is going to be my LRAM approximation for 4 rectangles under the sine curve from 0 to pi. So 35 is choice C. So again, if I want to see my work here, that's exactly what I would do. I just solve for those values for each of those sine functions, and I get choice C for that. And then 36, last one here, I got a truck that's moving with a positive velocity from 3 to 15. And then, okay, so what is the area, the big idea of this section, what is that area under a velocity versus time graph going to give you? And the area is that distance traveled. Again, we're going to get into this idea of distance, displacement later, but really we're looking for, this is the distance that the truck traveled between time 3 and 15. So the answer to 36 is letter D, and that is all of our problems for today. Hopefully you had fun, and we'll see you next time.